So welcome everyone. This is OneClass, and today my name is Shanjida. I am currently a human biology student at U of T, and today I'll be going over some commonly asked chemistry questions both at the high school / college and university levels. And if anyone needs any additional schoolwork help or tutoring, please check the description box below. And other than that, let's get started. Okay, so our first question here says, what is nickel? Okay, so basically nickel is an element, and so nickel, and the way the scientific way of writing it is Ni, lowercase I. So it is an element that consists of only basically it has one outer electron and valence electron, and it's part of the group 10. It has an atomic number of 28. So atomic number, what we mean by that is the atomic mass basically of it means the atomic number means the number of protons, means number of protons, right? So nickel has 28 protons, okay? And if we look at our periodic table right here, you can see it over here, it's part of the group 10. It has 28 number of protons, and therefore you can say that it also has 28 electrons, because the protons and the electrons, the number of protons equals to the number of electrons. So yeah, nickel is part of the group 10. It has 28 protons and 28 electrons. And so since it either can, it's one of those elements which can lose one electron, and it could also lose 2 electrons. So when nickel loses 1 electron, it becomes a positively charged cation. Okay, so it basically becomes nickel. You write it like this: nickel. Basically, and you have a 1 right here. Consequently, when it loses, when it loses 2 electrons, right, it will become, the proper name would be, so it will be nickel. So it would have, so it would be nickel 2 basically. Okay, and so these cations easily form ionic bonds with negatively charged atoms and covalent bonds with other molecules forming complexes. So one common use of nickels is probably mixing it with other metals called, so nickels are used in mixtures to or to create what are called alloys. Okay, and so stainless steel, for example, require so for example, stainless steel requires nickel to be added to a mixture of iron, carbon, and other metals. That's how you get stainless steel. So basically, nickel has application uses in the world. It has 28 protons and 28 electrons, and it's part of the group 10 elements. So this is correct. Number 2, what is the name of the compound P2O5? Okay, so what is the compound name, basically, of P2O5? Okay, so since the compound consists of 2 nonmetals, right? So 2 nonmetals. So answer P2O5 consists of 2 nonmetals, right? Phosphorus and oxygen. And so this is a covalent compound, basically. So it is a covalent compound. So the name of the element plus the prefix, right, is determined by the subscript, right? So the 2 and the 5. So is used, but for the second element, the suffix "ide" is used. So the second element in this case is oxygen. So when you're naming the compound, oxygen at the end, well, it wouldn't be oxygen. You would have to add "ide" to it. So as you can see, phosphorus has a subscript of 2, right? So while the second element, oxygen, so while oxygen has a subscript of 5, okay? So the prefix used when the subscript is 2 is di, because you have mono, di, tri. So for subscript 2, it would be di, and subscript 5 would be penta, right? Penta. So when the subscript, so the name of the compound, so when you put this together, so then P2O5, the way you say this is, diphosphorus. Sorry, I'll just write it here. So diphosphorus pentoxide. pentoxide. Remember how I said when you're naming the last element, you have to add "ide" at the end, so it would be diphosphorus pentoxide. Yeah, so note that the A in the penta was omitted because oxide already, the O is a vowel, so you won't really say pentaoxide, it's pentoxide. So this is how you say the name, and this is correct. Okay. Number 3. How can the pH of NaOH be calculated? Okay, so of NaOH. So NaOH is sodium hydroxide, right? So sodium Na has a charge of +1, OH has a charge of -1. So when you change the subscripts, basically, so crisscross, you get NaOH. So in this case, the pH, to calculate the pH, you need to know the concentration of. So when finding pH, you need concentration. You need to know the concentration of that substance. So for example, let's say we want to determine the pH of Na of, let's say, 0.2 molars of NaOH. Okay, so let's say, for example, we have 0.2 molars of NaOH. Okay, so I think you write it like this. Sorry. Molars. Actually, no, sorry. So yeah, you write it like 0.2. Okay, concentration. So first we need to basically find the molarity of NaOH in the solution. So since NaOH is a strong base, it will basically produce since NaOH is a strong base, so it means it will dissolve in water very quickly, completely. So basically, you can say it will produce so 0.2 moles per liters of OH, right? So because we're trying to find the pH, when it really says to find the pH of NaOH, we're trying to find the pH of OH in this case. So like the actual base in this case would be OH. So like Na is not counted because it's an element. So we're trying to find the pH of actually OH. So we have 0.2 moles per liters of OH ions. Okay, so let's say dissolved in the solution completely, and we have this concentration of OH ions. So we can find, so when we're dealing with bases, right? So in cases of bases, the pH is actually called pOH, right? And for if it's an acid, we're just dealing with pH. But I'll show you how you get pH from pOH. So let's say to find pOH, so the first step, this is basically the negative log the concentration of OH. So we can say it's the negative log of 0.2, right? And so we get around, so what we get here is 0.7. Okay, if you just put this in your calculator, and then to find pH, we just have to subtract this from 14, okay? So minus pOH. And what we get here is 14 minus 0.7, and you'll basically get 13.30 as your pH. Okay? So you can say the pH of NaOH is 13.30. Okay? And this is what they have got. So this is correct. Good job. Okay, so our next question says, what are polar and non-polar covalent bonds? Okay, so basically, when two atoms are sharing electrons, they form a bond. So partial transfer of electron density from one atom to another may occur, well, depending on the electronegatives of the two atoms, basically. So when we're talking about electronegativity, right? Electronegativity is basically charges due to unequal sharing of electrons. So basically, if we say an element which has a higher electronegativity, that means that electron basically tends to pull the electrons towards itself. So it's basically stronger. Okay, so when we're talking about polar covalent, let's say polar or non-polar covalent bonds, is basically the difference in the charges between the electronegativity between two atoms. So polar covalent is basically when you have an electronegativity difference. Electronegativity difference of, I think, between 1 and 0. I think it's around 1.2 to 1.5. Or I think it's like 1.0 to 1.2. So this is actually given. I think it's until here. So it's basically, it's partially ionic, not completely ionic, or else it would be an ionic bond. So it's partially ionic, but not completely. So that's polar covalent, basically. So they're like, it has a very so the central atom, basically, in this case, is very strong. Has a high electronegativity, and so I'll just write electronegativity. Okay, so the difference between those two would be really high, whereas when we're talking about non-covalent, this is usually when the electronegativity is basically the same between the two. The same or close, right? Or close of the two atoms. So this is basically a difference when you have a difference of electronegativity. So the difference in electronegativity is really low. Is small, so somewhere ranging from, let's say, 0.2 to 0.6-ish. So when you have an electronegativity difference of 0.2 and 0.6, this is considered as a non-polar covalent bond. Okay. I meant non-polar. Non-polar covalent. And so the electronegativity are given in a chart basically, and that's where you can find them, and then find the difference and determine if it's polar or non-polar basically. Yeah, so bonds with partially ionic and partially covalent are called polar covalent, whereas the electronegativities of the two atoms become equal or like have a difference of like 0.2 to 0.6 are non-polar. So in this case, methane is methane. In this case, right, CH4. It has carbon and hydrogen. So basically, the electronegativity between those two are almost equal. Okay, so let's say electronegativity basically. Okay, so let's just say electronegativity are almost equal. Whereas if you have H2O. Water, right? They have a big difference, so not equal. Okay. So partially negative and partially positive. So this is correct. So we have a question: is thiocyanate or SCN negative is a polar bond or non-polar? Okay, so SCN negative, which is also called thiocyanate, right? So in order to find the difference of the electronegativity of the atoms, so in this case there are 3 elements, and so you want to first find out the electronegativity. So just write electronegativity. Right, Okay, so we have here sulfur, carbon, and we have nitrogen. Okay, and so this, each of them, so sulfur has an electronegativity of 2.58. 2.58. Carbon has 2.55, and nitrogen has 3.04. Okay, so in this case you can see that nitrogen has a greater electronegativity, so it will tend to attract more electrons to itself. So since nitrogen has a greater, so I'm just writing electronegativity as that. Electronegativity, it tends to attract more electrons than, so it tends to attract more electrons compared to sulfur and oxygen. Okay, so if you want to calculate the difference, so let's say nitrogen, right, between nitrogen and sulfur, let's say, right, so you will have a difference, so let's say 3.04 minus 2.58, so you would have somewhere, right, so basically this would be, sorry, I would compare this with the least electronegative in this case, so it would be oxygen. Let's just say oxygen. 2.55. So it would be around 0.76, right? You can see that this is nearly close to 1. So therefore you can say, therefore SCN negative is a polar covalent bond. Okay. So yes, in a polar. This is correct. Okay, so our next question says, what is the molar mass of calcium sulfate? So, okay, so calcium sulfate. Okay, so let's first address how did we get this formula, basically, which is very important when you're dealing with molar mass. So calcium is from group 2, and you know from group 2 they all have a valence, has 2 electrons in the valence, in their final orbital, basically. So calcium has a charge of 2+, and sulfate has a charge of 2-, basically. Okay, so when you are trying to figure out the chemical formula, you just crisscross, basically. And so what you have here is CaSO4, since the ratio is 1 to 1, right? So then you have basically 1 mole of calcium, one atom of calcium and one compound of SO4 basically. So this is how you get the chemical formula. Anyways, when you're trying to find out molar mass, right? SO4. First, let's break this down into the individual elements. So in this case, let's first find the molar mass of calcium, and then the molar mass of sulfur. So in this case, we're breaking down sulfate also. So molar mass of oxygen. So we have 4 oxygens. Okay. So to find the molar mass, this is basically the same thing as your atomic mass unit of the elements basically. So if you recall that atomic mass is equal to number of protons plus number of neutrons, right? So it's basically the same thing for the molar mass also. So here's our periodic table, and we can literally find the molar mass, which is 40.08. This is 1 mole of calcium. So we have 40.08 grams per mole. Right? This is the same thing as saying the atomic weight, also atomic mass. So next, let's find the molar mass of sulfur. And so sulfur is right here, group 16, and you can see it has a molar mass of 32.07 grams per mole. This is 1 mole of sulfur. Then let's go to oxygen, and so 1 mole of oxygen is 16.0 grams per mole. But keep in mind we have 4 oxygen in this case, so we have to multiply this by 4. And so 16 times 4 is 64, and so we have 64 grams per mole. Okay? And so then, just erase this. And so to find the molar mass, calcium sulfate, just have to add all of the numbers together. So 64 plus 32.07 plus 40.08, and you get 136.15 grams per mole. Okay, so this is what I have got. Yes, so this is correct. So our next question says, what is the molar mass of aluminum sulfate? Okay, so aluminum sulfate. Okay, so let's first address how they got this formula. Okay, so break this down. So aluminum, right? If you see in our periodic table over here, you can see that aluminum is basically group 3, and so it would have a 3 valence electrons. So it would be plus 3, right? Since it needs to lose those 3 electrons other than gaining them. So we would have aluminum has a charge of plus 3. So, and then if we go back, so sulfate in this case, sulfate always has a charge of negative 2 basically. So as you can see how they have got the chemical formula, you just interchange the super subscripts, and so what you get is aluminum 2. We have 3 sulfates in this case and 2 aluminums, okay? So now we're just trying to find the molar mass. Al2SO4. Okay, so let's break this down into the separate elements first. So we have 2 aluminums. Okay, we have 3 sulfurs, so we just have to multiply the number of elements with the subscripts. In this case we have 3 sulfurs, so 3 sulfurs. And so sulfate has 4 oxygen atoms. Since we have 3 sulfates, we just have to multiply 4 times 3, and so we have 12 oxygens, okay? Okay, so to find the molar mass of aluminum, it's actually given in your periodic table over here, and aluminum has a molar mass of 1 mole of aluminum is 26.98. 26.98. Since we have 2, we have to multiply this by 2, so what we get here is 26.98 times 2. We have 53.96. Okay, so 53.96 grams per mole. And so sulfur, now we can see that it has a molar mass of 32.07. This is referring to 1 mole of sulfur, right? We have 3, so we have to multiply this by 3. And so we get 32.07 times 3. We get 96.21 grams per mole. So the lastly, oxygen, right? So we have basically 12 oxygens, and if you see from the periodic table, oxygen has a molar mass of 16. So this is 1 mole again. 16 grams per mole. So we have 12 in this case, so we have to multiply this by 12. And so what we have here is 16 times 12, we have 192 grams per mole. Okay, and now lastly, we just have to add all of the numbers together. And so just be 192 plus 96.21 plus 53.96, and I get 342.17 grams per mole. Okay, this is the molar mass of aluminum sulfate. And so, yes, this is what I've got. So, this is correct. Number 8, okay. So which of these molecules are polar? Check all that apply. Okay, so so basically polar molecules must contain polar bonds. So they should have, they should result from a non-zero net dipole movement due to the partial, right, this is like partial positive, partial negative, okay? And so we're trying to see if carbon dioxide, SO2, CH2, Cl2, and PCl3, so phosphorus chloride, is polar or not. Okay, so basically, to do this, we can also draw out the structures, and so let's firstly draw out CO2 in this case, okay? So basically carbon dioxide, right, if you draw this, it is a linear molecule, so it means it looks like this. And so since it's linear, if you add the vectors, basically, so this is partially negative, this is partially positive, right? Right, so the head in this case tends towards the more negative, and the tail is more positive, right? So if you add these two vectors, you basically get 0, okay? And so basically this is nonpolar, since it has a net dipole equals 0, okay? And so then now looking at SO2, this is polar, okay? Because if you want to draw this shape out, it's gonna be like this, okay? And then you have a degree of like an obtuse angle basically, and so you have basically a bent, right? So then this is not when you basically add these vectors together, you would have you would have a dipole moment basically. And so in this case, this is negative, this is partially positive. Actually no, sorry, this is positive and this is partially negative, okay? So this is polar, has a net dipole basically greater than 0, sorry. Okay, so now for the next one, we have CHCl2. Okay, this would be, so let's draw this structure. So we have C, this is going to be a tetrahedral. Okay, so we have 2 Cl's and we have 2 hydrogens. Okay, as you can see, this is a tetrahedral, and so this is called dichloromethane. And so if you look at the electronegativity of let's say of chlorine, basically we can say, sorry, electronegativity of chlorine, so it's 3.16, so, and carbon has around 2.5, I think, yes, so like chlorine is more electronegative, and so this is partially positive, and so basically it has a net dipole, and we can say it's a tetrahedral shape and it's asymmetrical, so it's not linear, so we can say polar since not linear but tetrahedral. tetrahedral. Okay. Okay, so our next one, we have monophosphorus trichloride, so Cl3. Okay, and so the way you basically draw this is, this is a trigonal plane, trigonal planar. So you have Cl, another Cl, and then one's going at the back, right? And you have two lone pairs. Okay, and so this basically is an angle, it's bent. And so this is phosphorus trichloride, and it is, as you can see, it is bent, and it's a trigonal pyramidal structure. So let's write that down. Trigonal pyramidal, right? It's asymmetrical, and so chlorine is more electronegative than phosphorus, and so this has a net dipole. So it's asymmetrical. So therefore this is polar. So in this case, the last, so like SO2, dichloromethane, and phosphorus trichloride are polar, whereas carbon dioxide is non-polar. Okay? Polar, okay. This is correct. Yes. Okay, so how is Q equal to MS MCT used? Okay, so Q equals to MCT. This is supposed to be delta T. This is used when you're trying to calculate specific heat capacity. Of the substance, okay? So basically Q is the amount of heat, right? Q is equal to heat in joules or kilojoules/kilojoules. Okay, no, I'll say joules or kilojoules, okay? And C is the specific heat. So this is actually a constant, basically. Sorry, not a constant, but it's unique for each substance. So this is called a specific heat. And in this case, the units for this is joules per mole Kelvin. Okay, and so to be specific, the heat of a material, the specific heat of a material is amount of heat required. So amount of heat required to raise, basically, required to raise the temperature of 1 kilograms of the material. Raise the temperature of 1 kilograms of the substance by 1 Kelvin, basically. Okay, so And so then we have and oh sorry, so M, I forgot to write down. M is the mass of the substance, in kilograms. Okay, and then lastly we have temperature, so delta T basically. So this is the change in temperature. So you basically have T2 minus T1, okay, in kelvins. And so basically we can say a positive Q, right, indicates energy. So we're calculating energy is absorbed, okay, is absorbed, so it takes in by the substance. So whereas negative Q indicates the energy is released by the substance. Okay, so this is how you use Q plus MCT basically. Yes, so this is correct. Okay, so the next question says, how many lone pairs are on the central atom in the molecule boron chloride, basically? Okay, so BCl3. Okay, and so first, this let's say what are the elements in this compound. So this is boron, right, and this is chlorine. So in this case, I can imagine that the central atom in this case would be boron, right? And it will have like chlorine would like basically be attached to it. So if we look at our periodic table, this is boron. It's in group 3, so you know it has has 3 valence electrons. So it's positive 3, right? So then when we are drawing this molecule, we would have 3 pairs of electrons, right? Because it has a valence electrons of 3. And so chlorine, right, has a valence electron, has 7 valence electrons, and it just needs to accept 1 more. In this case, we have 3. So we can just say 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, and then straw this nicely. Then you have 1, 2, 3, 4, 5, 6, 7. Okay. So the lone pairs in this case so boron has 3 valence electrons. Each of them are shared with each of the 3 chlorine atoms. So then chlorine has a full octet basically. So the boron only sharing 3 covalent bonds with 3 chlorine atoms will have 6 electrons in total, right? So as you can see, there is, right, 2, 4, 6. And so this is an example of an incomplete octet. So in this case, there are no lone pairs in the central atom of boron. So this is incomplete octet, right? And so boron does not have any lone pairs. Pairs of electrons. Okay. And so yeah, drawing the Lewis structure, the electronegativity are considered to determine. So boron has a lower electronegativity, and so since boron only has 3 valence electrons, they will be shared among the chlorine atoms. And so in this case, each of the chlorine will have a complete octet, but boron, on the other hand, sharing only 3 covalent bonds with 3 chlorine, will have 6 electrons in total. So boron will not have a complete octet, so therefore boron does not have any lone pairs. And this is correct. Okay, so now this question says, which is the formula for barium acetate? Okay, so now we're dealing with barium acetate. Okay, so the barium, so let's first write barium. So you have barium acetate. Okay, so barium, as you can see from the periodic table, let's see. Barium is over here, right, number 56. And so it has, since it's in group 2, it will have a valence electron, it would have 2 valence electrons. And so you can say that has a charge of +2, whereas acetate, so acetate is basically CH3 CO2 negative, okay? And so it has a formal charge of -1. And so when you're trying to find the formula or the chemical formula, you crisscross the charges in this case. And so what happens is you have barium right? You just change, and we don't really write -1 and 1 as a subscript. So we know that there's only one atom of that element. So in this case, A is the right answer, and you can see that B would not be right because barium has a charge of 2. When you crisscross, change the subscripts, you would have 2 acetate molecules. And BaMnO4, MnO4 is not the chemical formula for acetate. Same goes for CO3. CO3 is not an acetate. So in this case, this would not be the answer for barium acetate, because this D would be barium carbonate. Okay, and carbonate has a charge of -2. That's why they both don't have any subscripts. So the formula for barium acetate is A, Ba, and then you have 2 acetate molecules, and so this is correct. And so that was the end of our session. If you really like this Q&A, please subscribe to this channel, like, share, comment, and if you guys have any personal questions, you can follow the links in the description box and ask your questions. Other than that, Shanjida, I'll hope to see you soon. Bye bye.